Hello? So today we'll be talking about solving equations. So solving equations, whenever you're solving something, it means you have a problem that you don't know the answer to. And so we're going to look at how in mathematics where we have these equations, one side equaling another, and we have something unknown, we can solve for it. For example, simplest one would be if I say x equals 8, where I have this unknown variable x, and it equals 8. This was actually quite simple. It's already solved. Don't have to do anything else. But sometimes there are going to be things that you need to do, and it will involve operations: addition, subtraction, multiplication, division, exponents. And the cool thing is that we've already talked about how to use order of operations. Um, in this sense, though, in order to solve something, we're going to do order of operations backwards. And I'll go in more detail with that as we look at some examples. So, first of all, we have a very simple, what we call one-step equations to solve. And a one-step equation means you have one operation. So we'll look at four basic operations: addition, subtraction, multiplication, and division with this. So let's say we have x plus 3 equals 2. X plus 3 equals 2. Well, um, most of us nowadays will know what that is automatically because we'll just say, well, what number plus 3 equals 2? And that's going to be a negative 1. Well, how we actually solve it algebraically is the same thing. We know that we're looking for a number that would add to 3 to give you 2. So instead of adding 3, though, we're going to do the opposite operation of adding 3. We're going to subtract 3 on both sides. Now, the reason we're doing this on both sides of the equation is because it is an equation. That means the left side is supposed to equal the right side at all times. So if I subtract 3 on the left, I must also subtract 3 on the right. So from here, what ends up happening is that positive 3 and negative 3 added together will make 0. So honestly, you're always going to be adding 0 in this case. Now, anything plus 0 happens to be itself. So x plus 0 would just be x. And so we get x is negative 1. And we talked about how to add, subtract, multiply integers before, so I won't go into detail with that again. If you need some more practice with that, you can refer back to the instructional video, or you feel free to contact me. So in this regard, the operation that was occurring to x was addition. So we did the inverse operation of that, which is subtraction, to solve for x. Let's look at an example with subtraction. So x minus 2 equals 5. X minus 2 equals 5. So again, what is happening to x? Well, we are subtracting 2. Automatically, many of you are probably saying, well, that's just 7. That's quite simple. Well, it is. Let's say you didn't know that it was 7. Well, we can do the inverse operation of what's happening to x in order to solve for it. And that's what you will always do whenever you're solving equations, no matter how complicated it looks. So minus 2, the inverse operation of that would be plus 2. And what I do to the left side, I also have to do to the right side in order for this to truly be equal. It must remain equal, it must remain balanced. So when I solve for this, I end up with 0 again, and I get 7 here. So x must be 7. Now, in many cases, in books and online videos, in classrooms, which you were taught before, you would see them put a line through it and say it canceled each other out. That is true, it does. I tend to not use that terminology because it can be confusing to people. Because sometimes people think that when it cancels itself out, it makes 1. When we get to multiplication and division, which we're going to look at those examples next, sometimes people think that it becomes 0. And I'll just actually show you an example now. So let's say that 3 times x equals 9. 3 times x equals 9. Well, what number times 3 will give you 9? Well, the answer is 3. Okay, we'll say you didn't know that. 3 times x equals 9. What operation is happening on x? Multiplication. What's the inverse operation multiplication? Division. So we're going to divide both sides by 3. And 3 divided by 3 is just 1, so we end up with 1x. And 9 divided by 3 is 3. So 1x equals 3. Again, quite simple, which is the inverse operation. Now, as I said before, most times people will just say that this cancels itself out. Well, if you are always calling this canceling out and here it became 0 and here it became 1, you could see how this could be confusing to some people. And that is why I try to stay away from that. And if you're working with your own children at home or niece or nephew or whatnot, try to stay away from that, calling it canceling out. There's nothing wrong with it as long as they understand that when you're working with multiplication or division, it's becoming 1. When you're working with addition and subtraction, it becomes 0. If they can understand that, that is fine. However, most young people won't be able to see the difference. They'll just say cancel itself out. And if most of them understood this is 0, they may just call this 0. And we know this is not 0 times x, because 0 times any number is still going to be 0. So let's look at another example here. So let's say x divided by 2 equals 7. So x divided by 2 equals 7. Well, what operation is happening on x? That's easy. It's being divided by 2. Well, what is the inverse operation of dividing by 2? Well, the inverse operation of dividing by 2 would be multiplying times 2. And what I do to one side, I must do to the other, so that the equation remains balanced. All right. So 2 divided by 2 is 1. So we get 1x equals 14. All right. And those are our one-step equations. So why are they called one-step equations? Because you only need one step to solving them. Most of the equations that we do will be one step, two step, or they will involve parentheses in which you will have to do 2 steps. So before we move on to that, let's look at a very common one-step equation that will need to be solved. And it's actually one you already know. We used it when we were adding, subtracting, multiplying, and dividing fractions. Right? Remember when we had to change the denominator sometimes with adding and subtracting fractions? Well, that's what we're going to be doing here. That was a one-step equation to solve for an unknown. So let's assume that we have x over 5, and we are changing this to have a denominator of 10, and that this number is going to be 6. Okay, x over 5, and we need to change the denominator to be 10. And so this number is 6. Well, whenever we were doing this with adding and subtracting fractions, you knew in order to get the 5 to 10, I must multiply times 2. So I must multiply the numerator by that amount. Well, you can do the same thing here. But sometimes it'll be harder for you, depending on the numbers that are here, to realize that off the dome. But that's okay. If you can't realize it from just looking at it, there's a way that you can solve these still. And that is based off the fact that they are proportions. Well, if we think of this back to what we were just doing with the one-step equations, we have a number divided by our unknown. And so the inverse operation of that would be multiplication. So let's multiply. So I can multiply both sides by 5. 5 divided by 5 is 1, so we get x equals 6 times 5 is 30 over 10. So x is 30 over 10, and I'm done. Well, I'm not, because I know what 30 divided by 10 is. 30 divided by 10 is going to be 3. Now, again, many of you probably knew that from the beginning, or if you realize the fact that we're just changing 5 to 10, and to do that, you have to multiply times 2. Then what number times 2 gives you 6 will be 3. However, as you can see, we can solve for this proportion using our way of solving one-step equations. Now, this was not the only way to solve this equation, though. I could also have done what many call cross-multiplying. And this is a really, really good, useful tool. Whenever you have a ratio or fraction equal to another fraction, we can do what's called cross-multiplying in order to solve the equation. And all it is making a 2-step solution into one. So they usually draw lines connecting the numerator to the denominator of the other side, as you see here, in order to show that those are what they're going to be multiplying. And so when you do that, they get 10x equals 30. So 6 times 5 equals 30. 10 times x equals 10x. Quite simple. From there, how would you solve this? Well, this is, again, just a one-step equation. So now we will just divide both sides by 10. And then we still get x equals 3. So either way, we get x equals 3. And that is solving a proportion. Now let's look at a two-step equation. Two-step equation. So what is this really going to be used for in this class, in this course? Well, there will be a lot of equations that are used to talk about future value. Actually, in the next chapter, you're looking at percents and solving for what number is 10% of 6. Well, what number is 10% of 6? We can write that as an equation and then solve for the unknown, the what number, right? And actually, maybe at the end of the video, I'll show you a sneak peek of that. All right, so two-step equations. That's when you're having two operations occurring to x. So let's say, for example, we have 5x minus 4 equals 11. 5x minus 4 equals 11. So that means we have a couple of things happening here. So we have 5x minus 4 equals 11. Well, to solve for x, we need to think about this differently. If I knew what x was and I substituted a value in, would I subtract first? No, I would multiply that number by 5 first, then I would subtract 4. So that's order of operations. But we're trying to find out what x is to begin with. What number do we need to plug in to begin with so we can do order of operations? Well, with everything else, we're doing things opposite, or we're doing inverse operations. We're working backwards. So let's work backwards with the order of operations. And if you recall from before, the order of operations were parentheses first, then exponents or your roots. Then we have our multiplication or division, looking at what goes from left to right. And then we have our addition and subtraction from left to right. But to solve these equations, we're going to do that backwards. We're going to do our addition or subtraction, whichever occurs from right to left. We're going to do our multiplication, division, whichever occurs from right to left. And then we're going to look at our exponents. And then we're going to look at our parentheses and go inside of them, the parentheses, the groupings, whatever the groupings are, and we're going to do them the exact same way. We're going to start again at addition, subtraction, multiplication, division, and exponents. So if there's another set of parentheses inside, we'll go to that. But that is the order in which we solve equations. We do it backwards from how you do order of operations. So with that being said, here it is, we're trying to solve for x. And what operations occur to x? Where is times 5, and then there's subtract 4. So going backwards, we're going to look at subtract 4 first, and we're going to undo that operation. So to undo subtraction, or what is the inverse operation of subtraction? It's addition. So we're going to add 4 to both sides of the equation. Remember, you always do it to both sides because it is an equation. It is equal on both sides. So therefore, we must keep it equal. If we didn't keep it equal, then it would be off balance, and that would be wrong. So if we do this, we end up with 5x. Remember that these add to 0, or cancel each other out, but add to 0. 11 plus 4 will give us 15. And now we have 5 times x. So we're down to a one-step equation again. And this we know how to do. So to solve for 5 times x equals 15, the inverse operation of multiplication would be division. And so we would divide both sides by 5. And we end up with x equals 3. All right. So that is an example of a two-step equation involving multiplication and subtraction. Well, let's take a look at a different equation, shall we? All right. Well, this time, let's look at a over 3 plus 4 equals 12. So our unknown value divided by 3 plus 4 equals 12. Okay. So an unknown value divided by 3 plus 4 equals 12. Well, if I'm doing my order of operations backwards, as I said I was going to do before, then I must undo the addition of 4 first before I look at the division. So to undo the addition of 4, I do the inverse operation of adding 4. Now it would be subtracting 4. So I subtract 4 on both sides of the equation to keep it balanced. And I get that a divided by 3 must equal 8. Okay, well, that's quite simple again. A divided by 3 equals 8. Again, a one-step equation. So to undo the division, we multiply both sides. So we multiply both sides by 3. And we end up with A equals 24. All right, A equals 24. So that is going to be another two-step equation. This one involved division and addition. But regardless of what it looks like, you will always be able to solve by using order of operations backwards. All right. Now, the last type of thing you would have to do with solving equations is really complicated. Well, no, it's not. It's doing the exact same thing. The only difference is, you notice how each step, when we solve, we got one answer on the left side or on the right side. It just changed every single time to a different value. Well, in this case, that won't happen. So let's take a look at a problem that you will see in the future. Some of you will probably understand why I just laughed later on. So here is an equation for simple interest. We'll talk about that later on, some weeks. For a future value, so say you have a loan taken out and there's interest rate based on annually added to it. This is the formula that you would use to see how much you owe now on the loan, how much the loan is worth at that point, how much money that you have to pay them back as. Where this is your initial investment, R is your interest rate, change to decimal, of course, because it's normally given to you as percent. And T is your time in years. So if you had 4 months that you pay on a loan, that would be 1/3 of a year. It doesn't count up to a whole year. Sometimes when you get loans, they'll put little statements in there at the bottom that most people don't read the fine print, where it'll say stuff like, hey, if you pay this in 8 months, it's still going to count as 1 year. No. You can get them to change that. All you have to do is read the fine print. That's why it's very important to read those things before you sign. It's very important to read anything before you sign it. Anyway, that's a side note. Now, back to this. So, one common thing that's asked is, how do I know how much money I should put in? Say this was an investment, and I know what the normal interest rate is. Say it's like a money market account, something else that could be talked about later in the semester, but that you see in your book, or some other type of investment, and it's quite confident to say that I'll get a certain interest rate back for that if I leave it in. Just annually, there's a certain amount of money that I'm genuinely going to get back. Say if I'm supposed to get like 3% back every year, that's pretty good. If I put $1 in, I got 3% back. That's 3 cents. Okay, cool. I made 3 cents. Most people wouldn't care about that. But maybe if you're like, well, I get 3% every time instead of just putting that $1 in. You know what? I'm gonna put $1,000. I got $1,000 I can spare. Maybe you don't. Maybe you have 100 spare, or maybe you have a lot of money to spare, but you just want to see you just want a certain amount to be given to you. Well, you can solve for that. We can find out how much money I should invest if I wanted a certain thing, but I also could create a general formula because maybe I'm going to do this a lot. Maybe I'm going to do this for my family members, and I want to prove to them that this is how much money you should put in if you want to get a certain amount out. Well, in other words, I want to solve for the unknown P. I want to solve for P because that is, in this case, I want to know how much money I want to initially invest. I want to know how much the value it should start off as. I don't care about everything else because maybe ours, I already know what that's going to be. Time, I don't really care about time. Or maybe I know I need to get a certain amount within a year. And I already know what my amount is that I want. I just need to know how much do I start off with. So I'm going to solve for P. And a lot of times you'll see things written like solve for whatever the unknown variable is. So let's talk about how we would solve that. So in this case, what is happening to P? Remember, we're going to treat it how we did the other unknown problems when we had one-step and two-step equations. The difference here is we have a lot more variables. Doesn't matter. We're still going to do the same thing. Well, what's happening to P is it's being multiplied by this whole parentheses. Oh, but we're supposed to go order of operations backwards. Well, we are. Is there any addition or subtraction occurring that's not within the parentheses? No. Is there multiplication occurring or division? Yes. The P is being multiplied by this parentheses. So to undo the multiplication of that parentheses, we must divide by it. So we're going to divide both sides. And of course, all my markers are dying now that I'm on film. There's a good one. So we're going to divide both sides by the parentheses. 1 plus RT. And when I do that, remember these divide to 1. The entire thing divides to 1 because both of them have the parentheses set 1 plus RT. It's not 1 divided by 1 and RT divided by RT. That is not the case. The case is that the entire set of parentheses is being divided by itself. That is also a very common mistake made. Don't make it. So we end up with P equals A divided by 1 plus RT. All right, that's pretty cool. Now I know how much money I need to start off with in, say, an investment. If I want to get a certain amount and I have a certain interest rate and I know how long I want to have it stay in that investment for. I have a formula already set and I just have to substitute my values in. I can do that in Excel and see all kinds of different things. So that is solving equations. Let's look at one more example of solving for an unknown. We'll actually use the exact same. So remember A was P1 plus RT. Well, let's say I have a couple of different people saying, hey, you know what? You can put in this principal amount and this, and we guarantee you get this amount of money. And we have all these different interest rates from different companies. You know, you can invest in any one of them, and you just want to see which interest rate should you possibly go for, you know, or at least what you want to go for. So we want to solve for R in this case. All right. So I want to solve for R. I want to get R by itself. Well, we still do our order of operations backwards. The first thing we would do is get rid of P, right? Because that is the last thing that is occurring to R, because R is inside its parentheses. So we would divide both sides by P. And honestly, the parentheses aren't even there anymore. Why? Because there's nothing else that's going on in this equation right now except for what's inside the parentheses. So I'm going to get rid of them. And I'm still trying to get R by itself. Well, if I'm doing order of operations backwards, the last thing I see occurring would be addition. We're adding 1. So the inverse operation of adding 1 would be, yes, subtracting 1. So I subtract 1 on both sides. I get A over P minus 1 equals RT. Now, yes, I could come up with something different here than doing A over P minus 1. I could change this to a fraction of P as well and combine them together. But I could just leave it like this too. It's up to you what you want to do and how you want it to look like. That's the cool thing with math. You can change the way things look however you want. So the last thing that we're going to do here is we got to get rid of t. So what's really cool is that sometimes you may be asked to solve for t instead of r. And you can do the same thing that we're going to do here to get it by itself. Anyway, let's get r by itself. So we have r times t. So the inverse operation of multiplying would be, I heard you, division. So we divide both sides by t. And we get r is a very complicated looking problem, but not really. It's the final amount divided by the principal amount, or how much you start with, minus 1, all divided by the time. And there you have it. You have your equation. You have solved for r. And you could similarly solve for t. It's probably easy to see that instead of dividing by t, you would just divide by r. And you can manipulate this equation however you would like in order to find whichever part of it that you want to use however you like. And that is the end for solving equations. I will see you again soon.